Today we'll see how to do or how to perform experiment number 7. So it is the shortest path algorithm. So already we have seen the Dijkstra algorithm as a shortest path algorithm. So in this experiment we are going to implement the algorithm as per the working of the Dijkstra. Okay, so the Dijkstra shortest path algorithm, which is used for calculating the shortest path in the subnet from one node to another node. Okay. So for this we have already learned this particular algorithm in the class. You have to refer the book. So I'll just open that particular copy. Yeah, so this is the computer networks 10 mm book. So here this type of subnet has been given to you, and you need to identify the distance from source to or distance from any node to any other node. So for that initially you need to ask the user the number of nodes in the subnet, and you need to ask what is the distance between each node. Okay, so if the nodes has been directly connected, then you can enter the distance. If the nodes has been not directly connected, then you can enter the distance as 0. Okay, because they are not directly accessible. So these two things that you need to do. Another thing is that as all of you know that how this Dijkstra algorithm works. So initially, so suppose here every node basically has very two important, or you can say three important parameters. The first parameter is that whether that node is permanent or tentative. This is one of the parameter, means the label of the node. So if you see in this particular diagram, the nodes are either filled or unfilled. So you can say the nodes which are filled, they are permanent, and the nodes which are not filled, that is unfilled, they are tentative. So this is one of the parameter associated with the node, whether they are permanent or the tentative in the path. So if that node is permanent or that node is coming in the path, then we can consider that particular node as a permanent. Okay, this is one of the parameter. Another parameter, that if you see this figure B, every node initially having the two, like you can see this bracket. So every node has two things. The distance, if you see this bracket part, so there is two things. The first is written as a distance. It may be from suppose if we are started with source, then it may be a distance to the source. Okay, distance to the source, and via which path, that is a previous node. Okay, via which path we have to reach to that source, via which neighbor. So that is a predecessor node. So we are initially assuming that every node in the network are tentative. Every node in the network are tentative. Every node initially having infinity distance to the source, if you have started with source or maybe to the destination. So initially they have infinity distance, and we don't have any path. We don't have any path. So these three things you need to set initially. Okay, the first step that you need to do is ask the user to enter the number of nodes. Okay, then scan the distance between the nodes. So we are assuming that this distance from A to B, like distance from X to Y and Y to Z, are same. So here if you see the distance from A to B and B to A, it is 2, and that is one thing. And another thing is that if there is no direct link available, then you can set the distance as 0. Like for example here you can say A to C, there is no direct link available, so you can enter A to C distance as 0. Okay, and second thing that you have to do is that every node initially it is assuming as a tentative. So it is as 3 labels has been associated with each of the node. So initially all the nodes are tentative. All the nodes are tentative. Then initially all the nodes having infinity distance to the source, and we don't have any path. So initially it is dash. So this is initial thing. Now to find the shortest path, you can either you ask also one more thing to the user, that is who is a source and who is a destination, or you can ask the between which point you need to find out the shortest distance. Okay, so suppose if I want to find the shortest distance between A to D, so A will be the source and D is the destination, or you can say A to D, that means A is at one end and D is at another end, and we need to decide who are the intermediate nodes, so that our distance is shortest. Okay, so definitely A and D will be there in the path. So here this algorithm whichever given in the book, it has in the figure you can see that A is a source. So initially definitely A will be made as a permanent, And what is the distance from A to A? So A to A, the distance is 0 and dash, like initially it will be infinity and dash, so now it will be 0 comma A. That means A is having distance 0 to A via A, that you can update. Now after this node get permanent, after this A node get permanent, we are going to find who are the neighbors who has direct link to the A, who has direct link to the A. And initially you know that now right now there are two neighbors, B and G, but B is having initial distance as infinity dash, G is having initial distance as infinity and dash. But right now this distance at B will get updated. See, like A to B, what is the distance? It is 2. The distance is 2. Whereas earlier distance of B is infinity. So definitely 2 is less than infinity. So we are going to modify this distance at B point. So it becomes now 2. It becomes now 2 via which node? Via A. So we are concluding here that B having 2 distance to reach at A via A itself. Similarly, G is having initially here infinity and dash. That means he has like initially distance is infinity. But if you see, this direct link is available having distance 6. Now this 6 is less than infinity, which is the distance initially at G point. So here we can update this distance here 6 comma A. Now it becomes 6 comma A, like that. Now out of these two, now as there are two neighbors, out of these two neighbors, you can see which one is the shortest. So here you can see A is having two neighbors, B and G. B is having 2 distance with A and G is having 6 distance with A. So it means that who is going to be permanent in this path? B is going to be permanent. So you can see that B is get filled. It get filled. That circle has been filled. That means after this A, the next node will be B. Okay. Now what you do? Again, you can see the neighbors of that node. So who are the neighbors again? C and E are the neighbors. C and E are the neighbors of B. So C is having initial distance as infinity and dash. That means no direct path is available. Here infinity and dash. Now both the neighbors are going to update the distance, like C needs how many distance to reach at B? It is 7. It is 7 and B needs 2. So how much the C will need to A? Okay, I'll repeat again. C will need, or C has 7 distance to B and B has 2 distance to A. So that is 9 basically. If you do the total, it becomes 9, and definitely that 9 is definitely less than infinity. So you need to update here at B point via, that is B is having 9 distance to A via which node? Via B. Via B. Similarly for E point, initial distance is infinity and dash. Now you can make the sum of this distance between B to E. B2 is the 2 distance. It is 2. B to E is the 2 distance. So E requires 2 distance to B and B required 2 distance to A. So how much distance the E will take to A? It is 4. This 2 and this 2. It becomes 4. It becomes 4. Via which node? Via B. So it is get updated. If you see the next figure, C figure, the E will updated to 4B, that is 4 distance from A via B, and C will updated his distance from infinity to 9 comma B. 9 comma B. Why 9? Because this 7 plus this 2, that is 9 comma B. 9 distance via B. Okay. Again the same policy. Initially both of these are tentative. You need to make one of them permanent. So who is going to be made permanent? C is having 9 distance and E is having 4 distance to A via B. So both of this, out of these two, E and C, the E becomes permanent. Okay. And this algorithm will work forward. This algorithm will work in a similar way. Like the same thing that you need to do the implementation, and I have already uploaded the program which is already given in the book. So I'll just go to the just wait, yeah, let me check where is that particular program available. So this shortest part program has been already given, the algorithm has been already given in the book. So if you refer page number 369 from 5th edition of the Computer Network 10mm, so this routing algorithm, Dijkstra algorithm implementation details has been already given in the book. Okay, it is already given in the book, and the algorithm is very simple. So I'll just I have done the same program in the C programming, so I'll directly explain from that. Let me open the yes. So at the top I have written that you have to refer page number 369 from Computer Networks Tenenbaum 5th edition to complete this particular program. So let's have a discussion on this. So we are assuming that the infinity means we need to define what is the term infinity. So I have taken here 999. This is a big figure, you can take more than this. So we are assuming that nobody is having this much of distance between the nodes. So this is an infinity term, and maximum nodes also you may decide, it depends on you. Now distance is of having a two-dimensional array, because it's a 2D array, because we are saying that distance from I to j. So it's a two-dimensional, like we can say that distance between I to j, like that. Sorry, distance from I to j. So definitely it is a 2D array. So you need to define the 2D array. Okay, and you can say that the path is initially empty, but we need to decide which are the nodes which is there in the path. Okay, so here there is a use of a structure. Okay, so each node is having some state, as I said that each node is having some parameters in terms of state. So what is that parameter? That parameter, there are three types of parameters. One is predecessor, means who is a like previous node, that is a predecessor. Then length, and another is the label, that may be either permanent or a tentative. So here enumerator is used with the two labels, permanent and tentative, and this is a label. So each state or each node, you can say each node in the subnet is having three types of states. It is having three states. Okay, so what are the states? So first state is that I can start with the label. So the label of that node may be either permanent or either tentative. The distance from the source, or you can either start if you start with source, then it is a distance from source. If you start with destination, then it is a distance from destination. So in this distance is there, that I have shown in the bracket. So I hope you remember, in bracket we have seen that one term that we have given is infinity and dash. Okay, so this is very similar, like infinity is a distance initially that we are assuming, and dash is nothing but via which path, that is a predecessor, okay. So this is what the state, and this is the structure defined. You need to create an object here. So this structure variable is created as a state. Okay, now see here, you need to ask few things to the user. You need to ask the number of nodes, okay, how many number of nodes in the subnet, and then you need to enter the distance between that nodes, okay, that nodes. So we are assuming that the distance from I to j and j to I is same. Like if I say there is a distance 2 from A to B, then B to A is having distance 2 itself. Okay, and we are also assuming the second thing, that if there is a no distance, that is if there is no direct link available, then the distance is set to 0. So in this way you have to scan the distance between all the nodes, So this is a loop which is used for scanning the distance. So if you say that there are n number of nodes, so we need basically a nested for loop here, because we want the adjacent matrix distance from 1 to 1, 1 to 2, 1 to 3, 1 to 4, like that. So this is a the nested for loop has been used, and we are assuming that like if I and j are same, like for example if 1 to 1, so definitely 1 to 1 distance will be taken as a 0. Okay, so if I value, so if we are considering that this is a source and this is a destination, so like if both values are same, then definitely distance will be 0. Like distance between 1 to 1 is 0, 2 to 2 is 0, 3 to 3 is 0. Okay, otherwise you need to enter the distance. So if the I and j are not same, then you need to scan the distance between I to j. So that distance is taken into an array, two-dimensional array, that is distance array. Okay, now after this you need to again ask what is a starting and ending node. That means between which node you need to find out the shortest distance. Okay, so you need to ask the user what is a start node and what is a end node, that is a destination node. So I have taken here S and T as per our algorithm. S is the source and T is a destination. Okay, now this after that this is very important thing, like that in all of you know that initially we are assuming that, as I told you that initially we are assuming that there will be no any predecessor. Okay, I told you like that initially you need to take the two parameters, one is infinity distance and dash. Dash means I don't have any predecessor to reach and I have a distance infinity, maybe to the source, getting? So, and another thing is that also you need to take the label. Label is tentative initially. So for each of the node, each of the node you need to set this particular parameter. So here there is a use of pointer. Just wait. Yes. So initially we are assuming that the predecessor we don't have, initially we don't know any predecessor. So predecessor value is set to -1. Initially we don't know the length also, maybe to the source. So all the nodes is having initially infinity distance and the label of every node is considered as a tentative. Label of every node is considered as a tentative. So I can show you one image also I have here. So this particular subnet I have considered for the demonstration. So this is what the subnet that I have considered, and we are initially assuming that every node are tentative. Every node is having infinity distance. Okay, so you can see the parameter infinity and I don't know the predecessor also. म्हणजे अगोदरचा नोड आपल्याला माहिती नाही की ज्याच्या थ्रू हे डिस्टन्स आहे. So this is initially considered as a dash, getting? So that is -1 here it is considered. Okay, fine. After that we know that there will be two ends. We already know that, means if I want to find out the distance from S to T, so where S is a source and T is a destination, definitely S and T will be there in the path. S and T will be there in the path, but I need to identify who are the intermediate nodes between S to T. Okay, so either you can start searching from S node and you can reach to T, that is a destination, or you can start from T and then you can go to source. Like for example here, if I want to find out the distance between 0 to 4, either I can make 0 as a permanent and I can start searching from 0 itself, or you can make 4 as a permanent and then you can start searching from 4 itself back to source. So anyway you can do, but if you see this particular implementation in the book, so they have taken initially destination as a starting node. So that means if my if 0 is a source and 4 is a destination, I will start my searching from 4. See, if you want to find out the distance from 0 to 4, definitely 0 will be there on the path, 4 will be also there on the path. Intermediate nodes we need to identify from where we have a shortest path between 0 to 4. So 0 and 4 will be there, we need to identify the intermediate one. So either I can start from source and I can just go on searching up to destination, or we can start from destination and go on searching up to source. So in this book of Tenenbaum, they have given the algorithm by starting from the destination. See, they have given the algorithm by starting from destination. If you look at this particular, let me open. Yeah, so they have started with the destination. So let's see how this particular thing is done in the program. So S is our source and T is our destinations, and as I told you that you need to initially set this parameter for all the nodes. Okay, now we need to start the searching. So for starting the searching, here the state of T node means the destination node. So destination to destination length is definitely 0. So we need to set that particular distance as a length. As I told you that there are 3 parameters: length parameter, predecessor parameter, length parameter and label parameter. So this length is set to 0. Destination ची length 0 ला set केली आहे. That node is made as a permanent. permanent. And see, definitely we have started with the destination itself, so predecessor is not there, it is not required because we have started with destination towards the source. So length is initially made as 0 and label is made as a permanent. Okay. So for some further implementation, this t is copied into k value. Okay, now what is the next thing? So before going to the next thing, I just tell you. So suppose if I want to find out the distance from 0 to 4, let me open it with the paint so that you can understand it better. And just wait for 2 minutes. Let me open with the paint so that I can make the necessary changes in the diagram. Yeah. Yes, shortest part demo. I'll increase the font little bit. Yes. So initially it is dash and infinity. So right now, as we are starting with the destination, this will gone, and here what is the length? What is the length come? It is 0. The length will come as a 0. तुमची इथे length 0 होईल because this is our destination. So we are starting searching from destination itself. This node is initially made as a permanent. हा node तुमचा permanent होईल तुमचा. So this node will be permanent. Now what is the next step? What you need to do is that after this we need to search for the neighbors. So who are the neighbors? आपण neighbors कुणाला म्हणतो की there is a direct link available. Then we can call it as a neighbors. And then we need to identify what is the distance of the neighbors. We need to identify the distance at the neighbors as per this particular scenario. So look at here the distance, the neighbor of 4 is 1 and 3. Distance between 1 to 4 is 6, which is less than the distance at 1. So right now distance at 1 is infinity. Distance as 1 is infinity. And if you see the distance between these two, it is 6 plus previous node distance. So what is the previous node distance? It is 0. So 0 plus 6 is obviously less than infinity. So this infinity will gone here. Okay, it update will tumcha. So this infinity will gone, and here the 6 will come. So here it will 6 via which node? Via 4. Via which node it is? Via 4. Getting? Via 4. Similarly, this distance will get updated. So you can see that this distance is get updated. Okay, so it is 0 plus previous node is 0 plus this intermediate distance 5. 0 plus 5 is 5, which is less than infinity, which is earlier distance at 3. So it becomes 5 now. Okay, it becomes 5 now here. Via which node? Via 4. Let me write it properly. Distance is 5. Distance is 5 via 4 node. Via 4 node. Okay, via 4. This will get updated. Now out of these two, 1 and 3, who are you are making it as a permanent? Whichever is the shortest. So here it is 6, here it is 5. So which node you are going to permanent? Either 1 or 3, it is 3. 3 is going to be made as a permanent. Ready? Now you need to identify who are the neighbors of 3. Who are the neighbors of 3? So who are the neighbors of 3? Here it is 1 and 2. Okay, 1 and 2. Now update the distance at both the sides. Now earlier it was 6. Now it will be made as 5 plus 2, 7. But see, 7 distance is coming via, if you go via this way, the distance is 7, which is more than already available distance. So don't update it. Don't update this. This will be 6 only, because 7 is greater than 6. So we cannot update this. So this distance will get updated. So right now it is 5 plus this 1. So instead of infinity, so definitely 6, like 5 plus 1, that is 6, is less than infinity. So definitely this infinity will gone here. Okay, and here it will be 6 will come, 6 as a distance via which node? कोणता होता आपला 3 होता I think. So 3 via 3. Okay, so this way it will go on continue, and you need to continue this process until what? Until you reach to the source. Until you reach to the source. So same thing has been done here in the program. Okay, so previous thing, you need to do this destination as length as a 0, and make it as a permanent. Then you need to find out between destination to every other, because we don't know initially ki, how the direct, whether there are direct links are available or not. So you need to search for all the nodes. So what is the condition here? Distance between k to I. Who is a k here? K is our destination, because we are assign this destination value to the k. So k is our destination. So distance between destination and I should not be 0. It means that there should be a direct link available. म्हणजे तो नेबर असला पाहिजे, आणि जो कोण नेबर आहे तो काय असला पाहिजे, इनिशियली टेंटेटिव्ह असायला हवा. गेटिंग? सो दिस कंडिशन इज व्हेरी इम्पॉर्टंट. देन ओनली वी आर गोइंग टू अपडेट द डिस्टन्स. द लेबल ऑफ दॅट नेबर शुड बी टेंटेटिव्ह and there will be a direct link available. Direct link means the distance should not be 0. If these two conditions satisfied, then only we are going to update the distance. But still if it is updated, it is based on this parameter. आपण कधी अपडेट करू, तर distance of the k, length of the k plus distance between k to I should be less than the state of I dot length. ओके, म्हणजे प्रिव्हियस नोडचं जे डिस्टन्स आहे प्लस डिस्टन्स बिटवीन दिस प्रिव्हियस नोड अँड मी. इफ यू मेड ॲडिशन ऑफ दिस टू, इट शुड बी लेस दॅन माय ओरिजिनल डिस्टन्स. ओके, if we consider I as a latest node and k is its predecessor, then predecessor ची लेंथ, तुमच्या अगोदरच्या नोडची लेंथ, k आणि I मधलं डिस्टन्स यांची जर सम, ह्या दोन्हींची सम, it should be less than the previous distance of I. It should be less than previous distance of I. So what it means, what I want to say is that initially, if you remembered, here there will be infinity distance. Okay, here there will be an infinity initially, but right now we have added this 0 and 5 together, it becomes 5, and this 5 is definitely less than infinity. Then only we have updated this 5 here, otherwise no. Okay, so that thing has been made here. Yeah. Okay, and if this is true, then we need to set that k as a predecessor to I node. Okay, if this is true, then you need to do two things. You need to update the distance at I, and also we need to make k as a predecessor of I. So this two has been done here. So I node चा predecessor कोण होईल, k होईल, आणि I ची लेंथ किती होईल, तर k ची लेंथ प्लस डिस्टन्स बिटवीन k to I. And this loop will go on continue for every destination to every other node. Okay, जर असतील तर, म्हणजे त्याच्या सगळ्या नेबर्स साठी हे कॅल्क्युलेट होईल. Okay, so suppose there are two neighbors, and for these two neighbors this is calculated. Now out of that you need to identify who is a minimum. दोघांच्या मधला छोटा कोण आहे. For example, here in this figure, so the neighbor of like here there is a 4 value. So neighbor of 4 is 1 and 3. सो 1चं डिस्टन्स झालं आहे 6 आपलं, आणि 3चं डिस्टन्स 5 झालं होतं. तर ह्या दोघांच्यातला ठरवावं लागेल की परमनंट कोण, ह्या दोघांच्यातला ठरवावं लागेल परमनंट कोण. तर इथं 6 आहे, इथं 5 आहे. सो यू नीड टू मेक 3 ॲज अ परमनंट. ओके, अँड मेड दिस ॲज अ पाथ. सो दिस इज अ शॉर्टेस्ट पाथ बिटवीन दिस टू. गेटिंग? सो हिअर त्याच्यासाठी ही खालची लूप लिहिली आहे. सो फॉर, ओके, सो अगेन वी सेट द मिनिमम डेफिनेशन. आपण मिनिमम म्हणतोय, पण मिनिमम आत्ता आपल्याला माहिती नाही. सो वी सेट इट ॲज इन्फिनिटी. ओके, देन सी एव्हरी दॅट पर्टिक्युलर लेबल शुड बी टेंटेटिव्ह. लेबल टेंटेटिव्ह असायला पाहिजे, आणि स्टेट ऑफ आय म्हणजे त्या नोडची लेंथ जे आपण कॅल्क्युलेट केले त्या नोडची लेंथ. आता हिअर इट विल लुक फॉर ऑल दी नोड्स, but definitely these two conditions need to be satisfied. The state of label of I should be tentative, and length of I should be less than minimum. तर आता आपण minimum infinity, we have assigned minimum to infinity. Okay, so in our example it is 6 and it is 5. So definitely both are less than this one, less than infinity. So it will search for 1. So it is 6 is less than infinity, fine, this is okay. But still we get another node, that is node 3, which is having distance 5. So we'll made this as a permanent node. So see, that has been done here. दोन्हीमधला परमनंट आपल्याला ठरवावा लागेल कोण आहे. ठीक आहे. सो इफ दिस इज ट्रू देन वी आर गोइंग टू असाइन दॅट स्टेट ऑफ आय ॲज अ मिनिमम. जर सपोज आता 6 सापडलं तर 6 मिनिमम होईल. पुढच्या वेळेस 6पेक्षा सुद्धा अजून कमी डिस्टन्स असणारा नेबर सापडला तर दॅट विल बी बिकम युअर मिनिमम. ओके. अँड द व्हॅल्यू ऑफ दॅट आय, त्या आयचा जो नोडचा जो लेबल हे आहे, द व्हॅल्यू आहे दॅट विल बी असाइन टू के. अँड वी मेड दॅट स्टेट ऑफ के. ओके. the label will be made as a permanent. So here we can say that here it is 6, so 6 is less than infinity, fine. Okay, so we'll get minimum. Initially minimum is infinity. Okay, but as per our searching we'll get 6 as a minimum, so minimum becomes 6. This is for one neighbor. पुढचा नेबर बघितल्यानंतर आपल्याला लक्षात येते की हा 5 आहे. So 5 is again still less than 6, so now our minimum becomes 5. Okay, minimum becomes 5 like that. So here it becomes 5. म्हणजे हा नेबर आपल्याला सापडला 6 वाला, बट त्याच्यापेक्षा सुद्धा छोटा आहे 5 वाला. सो विल मेड दिस ॲज अ परमनंट. तर त्या लूपमध्ये बाहेर येऊन फक्त त्या लेबलला काय केलं तर परमनंट केले. दॅट पर्टिक्युलर नोड लेबल हॅज बीन मेड ॲज अ परमनंट. वेअर व्हॉट इज दिस के? दिस के इज नथिंग बट दिस आय फॉर विच द डिस्टन्स यू फाइंड ॲज अ मिनिमम, लेस दॅन मिनिमम. ओके. And you go on continue this particular process until we'll reach to our source. As we know that in this algorithm we have started with destination, so we need to check whether we will continue the same loop until we reach to the source. Okay. म्हणजे प्रत्येक नोडचा काय काय ठरेल की प्रेडिसेसर कोण आहे हे ठरेल, त्याची लेंथ किती आहे हे ठरेल, आणि whether that node is permanent or tentative. So these things has been decided in this entire do while loop. Okay. So I'll repeat in short. You need to identify that neighbor distance you need to update, and out of the neighbors you need to choose the neighbor which is having minimum distance. Getting? These two things has been done over here, and to that particular neighbor we are giving the label as a permanent. Okay. Now the last step is to print the path, and for printing the path, so here in this above we have went from destination to source. Now let's print the path from source to destination. तर तुम्हाला काय प्रिंट करत यावं लागेल? प्रत्येक नोडचा प्रेडिसेसर प्रिंट करत यावं लागेल. प्रत्येक नोडचा प्रेडिसेसर प्रिंट करत यावं लागेल. and for that initially I will be set to 0. Okay, so path of I is k. Initially s will be get printed. S means source will get printed. Source will get printed on the screen. Okay. After that you need to print that particular source. After that त्याचा जो predecessor असेल, okay, predecessor of that node, because k is a source now. Okay, k is a source now, so we'll print k first or s first, and then we need to identify. Now the k becomes predecessor of k, that is that becomes k. Okay, and this process you need to repeat until all the predecessors get printed, until all the predecessors get printed. So for example, in our case here it will be 5, now it will be get updated to 6, and this will be get updated to 7 like that. So this is one way of doing. So here this will be made as a permanent, this node will be made as a permanent. Okay, so this is a source suppose, and then we can do the back tracing by printing the path from source to destination. So who will be predecessor of 0? Predecessor of 0 will be 2. Who is the predecessor of 2? It will be 3. Who is the predecessor of 3? It will be 4. So this path will get printed. Every time you need to print the predecessor. So initially 0 will get printed. Next predecessor of 0 is 2. 2 will be get printed on the screen. So it will be 0, 2 like that. So predecessor of 2 will be 3. So 3 will be get printed on the screen. After predecessor of 3 will be 4. So 4 will be get printed on the screen. So this way the path is get printed on the screen. Okay, and for printing this path, this following this the last do while loop is used. So initially the k value is s. So we have started printing from source. The source get printed. Okay, and then त्याचा जो प्रेडिसेसर आहे, केचा जो प्रेडिसेसर आहे, के मीन्स अवर सोर्स, सो दॅट विल बी कन्सिडर्ड ॲज अ के. Again that k is printed and predecessor of that will get printed. So every time this loop will get continue until all the predecessors get printed. See, because why it is written as greater than 0, because initially we made predecessor as -1, predecessor as -1. Okay. So you can see this particular program that has been already given in the book, and you can see the execute this particular code. And I have already given in the experiment I have given the detail how this particular shortest path Dijkstra algorithm is going to be work. And then in the lab you need to perform the C program and implement the program. So I have already uploaded the program on the Moodle. You need to simply understand the concept, okay, ki what exactly the procedure that has been get followed in the Dijkstra algorithm. Okay, fine. So I am going to end now.